and fractional exponents. We're going to be answering the question, how can I rewrite it? So for question number 36, it's going to talk to us about fractional exponents. What happens when an exponent is a fraction? Consider this as you answer the questions below. For part A, they want us to calculate 9 to the 1/2 using your calculator. Okay? So if you have your own calculator, great. If not, you can use the Desmos Scientific Calculator. But basically, you're going to type this base of 9. You're going to use this button that's called a caret. It looks like a little arrow pointing up. And then in parentheses, you're going to type the fractional exponent, 1 divided by 2. And then you're going to hit either your equals or your enter. And it's going to give you this first answer of 3. Now we're going to calculate, also use your calculator to calculate 49 to the 1/2 power. So we're going to type in the base of 49. We're going to use the caret button. We're going to type in the fractional exponent of 1/2 as a division problem. Hit enter, and the second answer is 7. Now we want to do this one over here. 100 is the base. We're going to use the caret button, type in the fractional exponent of 1/2, hit the equal sign, and we get 10. Okay? I want everybody to write down the calculator steps. The calculator steps, you're going to draw the caret button, and then you're going to put the exponent in parentheses, 1 divided by 2. Then you either need to hit equals or enter. Just depends on what your calculator has. Some have equals, some have enter. Okay? The question asks, what effect does having the 1/2 in the exponent appear to have? It appears that it has the square root of the base. Okay? What is the square root of 9? 3. That was our first answer. What is the square root of 49? 7. That was our second answer. What is the square root of 100? 10. That's our third answer. So it appears that it has the square root of whatever the base is. Okay? Part B says, based on your observations in part A, predict the values of 4 to the 1/2. We're just doing that one right now. We're going to type it in the calculator. You would type in the base of 4, use the caret button, put the fractional exponent, hit equals. We take the square root of 4, which is 2. Okay? If we do that with 7 to the 1/2, then we square it. Here's what that will look like. This one's a little bit trickier. So you're going to take 7. You're going to use the caret button. Type in the exponent of 1/2. It gives you this crazy decimal. So we want to square that because outside the parentheses there's another square. So I'm just going to square it. It types in the answer for me, the previous answer, and then it squares it, hit equals, and we're back to 7. Okay. All right, question number 37 says Danielle wants to understand why 9 to the 1/2 is the same as the square root of 9. Since exponents represent repeated multiplication, Danielle decided to rewrite the number 9 as 3 times 3. She then reasoned that 9 to the 1/2 is asking for one of the 2 repeated factors with a product of 9. Using Danielle's logic, what is the value of 16 to the 1/2 power? Confirm your answer using your calculator. They're asking what number is being repeated twice to get 16. Hopefully most of you know that's 4 times 4 or 4 squared. If you type it into your calculator to confirm it, you would type 16 caret, type the fractional exponent, and then hit the equal sign. Okay. Part B says, what is the value of to the 1/3. So you can type it in your calculator as 8, caret button, 1 divided by 3. It'll give you 2. But what it's really asking is what number is being repeated 3 times to get 8. That would be 2. Okay? They want you to rewrite each number as 3 repeated factors. So what number repeated 3 times is going to get you 125? That would be 5. And then you can use your calculator to confirm it if you know how to type it in there correctly. All right? Part C says, what about 27 to the 2/3 power? So we want to know, because of the 3 right here, what number is being repeated 3 times to get 27? That would be 3 times 3 times 3. We need to take that number and take it to the power of 2. So 3 squared, or 3 times 3, is 9. Okay. Same thing with 32 to the 3/5 power. What number is being repeated 5 times? That would be 2 times 2 times 2 times 2 times 2. That's a lot of 2's. We need to take that 2 and take it to the power of 3. So 2 times 2 times 2 is 8. You can double check it with your calculator. The third one is 25 to the 3/2. What number is being repeated twice? That's the denominator. That would be 5 times 5. So we need to take that 5 and take it to the 3rd power, which is the numerator. So 5 times 5 times 5 is 125. You can confirm it by checking it with your calculator. Part D says, another name for x to the 1/3 is cube root. This can be written as the 3rd root of x. What would be the notation for x to the 1/5? For x to the 1/5, we would take the 5th root of x right here, and it will be called the 5th root. Okay. Can you close your Chromebook for me, please? Thank you. At the top of page 10 is question 38, which is titled Exponent Law for Rational Exponents. Addison's teacher challenges his team to use algebra and the properties of exponents to prove that the square root of 3 is equal to 3 to the 1/2. Addison says, well, let's assume there is some exponent that will give us the square root. Part A, Addison writes the equation the square root of 3 equals 3 to the x. Imani says, I think we should start by getting rid of the square root. What operation will undo the square root? Okay, so CPM calls it undo. We call it inverse operations. And the inverse operation of square root is squaring. And the opposite operation of squaring is square rooting. Just like addition and subtraction. If addition is happening and you need to undo it or inverse it, you would do subtraction. Subtraction and addition undo each other. Just like multiplying and dividing undo each other, or our inverse operations. Okay? Part B says, starting with Imani's idea, solve the equation the square root of 3 equals 3 to the power of x for x. What does your answer mean? Okay? So they give us the square root of 3. We want to do the inverse operation, which is to square. So we're going to square both sides. When you square something that's being square rooted, you get the number inside, which is 3. When you square 3 to the x, you get 3 to the 2x. Then you have the same bases. Notice on the left side of the equation, you have a base of 3, and on the right side of the equation, you have a base of 3. When you have the same bases, then the exponents must be equal to each other. So we can say that the 1 is equal to the 2x. That only happens when the bases are the same. If this was a 3 and this was a 7, it wouldn't work. It only works because you have a 3 and a 3, same base. Then you just solve by doing the inverse of multiplying by 2, which is to divide by 2, and you get x equals 1/2. So you're just proving that the square root of 3 is equal to the 3 to the power of 1/2. Same thing with part C. You're doing the same thing, except for now it's going to be the third root instead of the square root. So the inverse operation of the third root is to cube. So we're going to cube both sides. Then we have the same base of 17. You have the same base. You can set the exponents equal to each other. And then do the inverse operation of multiplying by 3, which is to divide by 3. The last question, number 39, you're going to do in your groups of 4. It says, now that you have many tools to rewrite expressions with exponents, use these tools together to rewrite each of the expressions below in 2 different ways. The example they're giving you is that the square root of 2 to the 5th is equal to 2 to the 5th to the 1/2. 1/2 is the same as the square root, so they're just rewriting it. Then you combine those 2 exponents by multiplying them together. 5 times 1/2 is 5/2. Okay? So you really only need to do 2 problems here because I did the first one for you. The square root of 3 to the 4th power, you rewrite it as 3 to the 1/2 to the 4th power. Then you multiply the exponents. 1/2 times 4 is just 2. Then you can just simplify that one. You can't simplify all of them, but this one you can. 3 squared is equal to 9.